Go.
So now we're going to run our actual experimental tests. We're going to see what sort of materials are in a variety of foods. You've got a table, the very last table in the lab, that has the list of foods. And you'll notice that it has a big box on every column for results. So that's what happens when you run the test. And then you have a column that says yes or no. Is there sugar? Is there starch? Is there protein? Is there lipids? That's what you're going to be. And you'll notice there's a little box on each line for color control. Now, color controls only are necessary when they're necessary. Is that if you're running a test that doesn't really have a color change, you don't need to run a color control. If you're running something that changes, like the Biuret changes to purple, there are no purple foods. We don't really need to run a color control on the Biuret for the foods. But for the Benedicts, where some of the foods match a color that's a Benedict's positive, you're going to need to run a color control. And I will do that for just a few of the foods. And sometimes for the Lugol's, there needs to be a control as well. We'll have to see if we get that. We're going to start with two tests that we can kind of run in sequence. And that's the grease spot test for lipids and the Lugol's test for starch. Now over here on the table, this would have been set up for your lab. There would have been a heck of a lot more stuff here than this, because I would have had it set up for the whole room, but this is just set up for me. What I'm gonna do is one by one, and you'll see me do it. I'm gonna take a piece of carrot. Over here I've got a spot on my paper for carrot. I'm gonna try to rub it and get it to make a wet spot, which it really, really doesn't want to do. Ah, there we go. And when that sort of dries, it still looks wet and light will come through it, that's an indication that there's lipids in the carrots. And I was just gonna put the piece of carrot on the other piece of paper. Now here's something that never ever works, but I'm gonna show it to you anyway. The bread. There is no way in the world you can make a wet spot with, I had one type of Italian bread years ago I could get a sort of a wet spot with, but all it does is crumble. So I'm moving the bread over to the other paper. Potatoes you have to be careful with, because if you're not careful, I'm gonna crack this because pretty easy to make a wet spot with the potatoes. You don't want a wet spot so big that it takes forever to dry out. So I'm gonna move the potatoes over here. Same thing's true for the apple. I'm gonna crack the apple, get myself a nice wet edge, make some wet spots with the apple. Move the apple over here. The meat, this is ground beef. I tried to get the least lean ground beef I could get at the store. That turns out not to be easy anymore. And that I can actually make a pretty decent wet spot with. Move that over here. I now need to clean my hands. The other things didn't really leave residue on my hands, and I was touching the top of the pieces anyway. Because that's a problem with these, is contamination is a really big deal when you're going from one food to another. Here's a piece of walnut. I'm going to crack the piece of walnut and rub it on the paper. I will tell you that having not run these tests in many, many years, I don't think I realized how important it is to crack the piece that you get, because after it's been sitting on the table for a while, it dries out. So doing this, I'm changing my instructions for my classes. Oh, I forgot, I need to put a piece of walnut over here. Now, I've got a spot on here for milk. I'm just gonna put a small drop of milk. I have a spot for regular soda. I have a spot for diet soda. This is Mountain Dew. I got it because it needs a color control for the Benedicts because it's greenish yellow, which is a positive for Benedicts. And when you mix greenish yellow with blue Benedicts, it turns green, even though that's not a chemical reaction. So I'm going to take this paper, and like we did with the first set, I'm going to kind of shake some of the residue off. Set it aside and let it dry. Some of the drops will dry completely and some of them won't. So now we come over here. we're gonna run the Lugol's test on the pieces. So I'm gonna put drops of Lugol's directly on the foods and see if we get a change to black. This only takes one drop. So drop of Lugol's on the carrots. Carrots are always tricky to read. Remember, Lugol's is very dark, and the middle of the carrot is kind of dark. I'm going to try another drop that hits the middle a little bit better. This is one of the fun things about a chemistry test. You're looking at it going, did it change? Do you think it changed? What color do you think it is? I imagine a bunch of chemists in a room setting up the directions for these things going, what color do we tell them that this changes to? I would say that you're getting black in the middle there. You can interpret it your own way. And the thing is, your yes or no just has to match your particular results. So if you don't think it turned black and you write that down and you say, no, it doesn't have starch in it, that's okay. Okay, we're putting Lugol's onto the bread. That's a pretty clear change. Putting Lugol's onto potatoes. That's a pretty clear change. Lugol's onto the apple. Little bit, right? You get flecks of black in the drop, which probably would suggest that if there's starch in there, it's not evenly distributed through the whole apple. Lugol's onto the meat. Soaks in pretty well. Turns the paper black for sure, but it does not seem to have changed the color of the meat. And onto the walnut. I may need to tilt that drop off so that it isn't, a really thick drop is dark. Turning the paper black. Spread out on the walnut. I leave it to you to decide what you're seeing. Now, I need to set up test tubes for the liquid foods. So, come on back. This is the milk. We're putting 2 drops of Lugol's into the milk. And I would say we're not getting a black there. Set up the regular soda. 1, 2, 3, 4, 5, 6. 2 drops of Lugol's into that. 1, 2. Kind of pretty. Pretty is not a scientific result, although it's something you often get. And the diet soda. 2 drops of Lugol's into the diet soda. 1, 2. A very similar pretty. So write the results down that you see. The apple is a little bit more convincing now. The carrots is a little bit more convincing now. And put your interpretation. Is there or is there not starch according to the tests? Here, I'll put that against the lighter background. Got the milk, the regular soda, and the diet soda. Okay. How far in are we?
9 minutes and 16 seconds.
Okay. We're going to run our B-red test on these foods. What I did, because I need the chemical to really mix well, so I need a lot of surface area, I ground up the foods that can easily be ground up, and I put them in the bottom of these test tubes. So, you see, there's ground carrots and bread and everything is ground up in there. Now, obviously, this is not 6 drops of carrots. So following this directions that say put 6 drops of whatever in, what I want is to see if the colors change. So I gotta put plenty of reagent on this. And then I gotta give it a couple of minutes to change. So that's what I'm gonna do. I'm gonna use my paper to give you a little bit of contrast. And, yeah, okay. So you can tell which foods they are just by looking at them. Okay, I'm gonna actually pour. Pour and mix. And give it a couple of minutes to check. Pour and mix. Pour and mix. Pour and mix. Mix. Pour and mix. Pour and mix. Pour and mix. Remember, we don't need a color control because we didn't start with any purple foods. Purple is the positive for Biuret. Okay, we're a minute into our 2 minutes. You can see some of the stuff has changed some color, but right now we're really just seeing the blue color of the Biuret to start. This is when it really gets fun. That purple? I don't know, is that purple? It's got protein in it, doesn't it? Well, yeah. Maybe the protein doesn't come out into the mixture. I don't think I need to mix that, or the liquids. Okay, we're coming around on 2 minutes. So the question now is, what colors do we have? This is the carrots. This is the bread. I would interpret that as a very slight purple. This is the potato, definitely changed, but again, the Biuret is a base, so it does have chemical reactions with some of the stuff. That's the apple. That is the meat. I leave it up to you as to whether you think you're seeing a reaction. That is the walnuts. That is the milk. It's whole milk, incidentally. And that is the regular soda and the diet soda. It's interesting that those changed to different colors. Neither one of them's a purple, but they changed to different colors. So those are your results for your Biuret tests. So we have 2 more columns to do. We have the grease spot test. That's still sitting over there drying. And we have the Benedict's test, which is going to involve putting a whole bunch of Benedict's on food and putting it into the boiling water. So that's going to take a little bit of time. So we're going to do that on the second video. So we're going to stop here.